All right, good morning, everyone. It's 10 o'clock, so we're going to go ahead and get started. Welcome to the 2023 CRB Webinar Series. Today's webinar will provide a look at how tree density and pruning affect the maturity of navel oranges. My name is Caitlin Stanton. I'm with the Citrus Research Board, and joining me today I have McCall Machado, who will be monitoring the chat, and Dr. Joey Mayorkin, who will be introduce our speakers. Just a little technical information before we start. Please note that the webinar is geared toward growers. Master gardeners can certainly benefit from participating, but if there's any pest management methods shared, they should not be followed without a clear understanding of legal use in their home environments. And we encourage you to ask questions throughout the webinar. Please utilize the Q&A function on Zoom. We will be having Craig answer all of the questions at the end of the webinar. And with that, I'm going to pass it over to Joey, who is going to introduce our speaker for today.
Thank you, Caitlin. It is a pleasure to introduce today's speaker. Please help me welcome Craig Kallsen, UC Citrus and Pistachio Farm Advisor for Kern County. Prior to his UC Farm Advisor position in Bakersfield, Craig worked 4 years in pest control, nutrition, and irrigation for a large commercial citrus company out of the Central Valley. Craig is a co-author of the Pruning chapter in the latest University of California Citrus Production Manual, and has been closely involved in writing the orchard establishment and production cost studies in cooperation with the Agriculture and Resource Economics Department at UC Davis. Today, Craig will go over how tree density and pruning affect fruit number, size, quality, as well as maturity of navel oranges. Craig, please go ahead and share your screen to begin the presentation.
Again, as Joey said, I'm Craig Kallsen, the University of California Cooperative Extension Farm Advisor in Kern County. And I'm going to talk about tree density and pruning, how they affect fruit numbers, size, quality, and maturity of navel oranges. Plants have the marvelous and often underappreciated ability to use the energy and sunlight to turn water and carbon dioxide into food. People can't do this, but what we can do is affect how and how much of the incoming sunlight on an acre of ground is captured by crop plants. We can do this in a number of ways. The 2 ways I'm going to talk about are through tree planting density and our pruning. So in citrus, tree density and pruning can affect harvest maturity, yield, fruit size, and quality. And of course, those things all affect the grower's economic return. So I'm going to talk about tree density first. So not all tree densities are equal. So the response a grower obtains from a given tree density is dependent on many variables. For instance, row orientation. Are the rows going east, west, or north, south? Orchard design. For instance, the distance between trees down the row and distance between rows. The level of fertility and irrigation, the choice of variety and rootstock, the local climate in general, but annual weather can be different from year to year. Unfortunately, there's very little research has been done in California of the effect of planting density on yield and fruit quality. There is a study, it's an older study, it's from a large replicated navel orange on Troyer rootstock tree spacing trial near the southern end of the San Joaquin Valley in Kern County. It was planted in '61. And they continued to collect data at least through 1974. These are difficult studies to do. So I think we're fortunate at least to have this study. The Troyer is still a rootstock that's still available. It's very similar to Carrizo, which is one of our standard orange rootstocks in the Central Valley. And the variety was actually Frost New Cellar, which is not planted anymore. There's still a lot of blocks on them, but pretty similar to the Washington Navel. So the objective of this particular research was to determine the effect of tree density on a number of variables, such as rate of color development of the fruit, the intensity of color development of the fruit, fruit size, development of the sugar-acid ratio in the juice of the fruit, yield, and net income. So in this experiment, tree density was manipulated by changing the number of trees in a row and the distance between rows. And as you can see, some of the spacings were very close. For instance, this 9 by 11 refers to 9 feet between trees down the row and 11 feet between rows. And they had quite a range of different tree spacings. The widest spacing was 22 by 22. That gives you something like 90 trees per acre. And some of these closer densities had to be modified as the trees grew because they simply couldn't get equipment into the grove, and so it had some other problems. Let's look at what they found out with orange color development first. Orange color developed first in the 22 by 22 foot spacing. Again, these were Frost New Cellar navels. Fruit color was delayed as much as 45 days after reaching legal maturity, which back then was an 8.0 in close tree spacing. Orange color was more intense in the 22 by 22 foot spacing. So the take-home message on this was for earlier and more intense color development, plant trees further apart. Of course, you can always plant an early navel and get early color, but even amongst that particular variety of early navel, in general, you're going to get earlier, more intense color by planting the trees further apart. Fruit size, individual fruit size on average was larger in the wider 22 by 22 foot spacing. So for larger fruit size, plant trees further apart. For reduced fruit size, plant trees closer together. Let's look at the rate of development of the sugar acid ratio in the juice. Here's data from at least one of their studies. And here we have the sugar acid ratio increasing as we go up the y-axis. Here's the harvest dates here going across the bottom. And again, they were looking at, these are fairly early harvest dates, even back in the 1960s. And you look at the less dense planting, the trees further apart, it's the red line. The highest tree density would be this sort of greenish white line down here. And here's what was legal maturity, 8.0, which is still a good baseline that we use today in many ways. So notice that the red line crosses the legal maturity line first, a little before October. Whereas here at the highest density, we cross the line somewhere probably around November 5th. And we got all these ones in between. This is pretty good data showing that if you want an early sugar acid ratio, perhaps to take advantage of the early navel market, you want to plant the trees further apart, less densely. So higher sugar acid ratios were produced earlier in the fall in wider spacings. And in this particular experiment, tree space 9 by 15 were 11 days later and reaching a sugar acid ratio of 8.0. This is some data from an experiment that I did with Blake Sandin a number of years ago with Beck navels. And one of the things we looked at was the side of the tree. These were east-west running rows. And we found that on the south-facing side of the tree, that we developed sugar much more quickly. By September 29th on the south side, we had a 9.1 sugar acid ratio, whereas the fruit on the north-facing side was only at 6. October 24th, we were up to 10 on the south side of the tree and only 7.2 on the north. So illumination is important. So if we can get more light hitting the tree, we get more warmth and more light, more photosynthesis. The fruit maturation seems to become earlier. So for faster development of a higher sugar acid ratio, plant trees further apart. In general, to increase rate of fruit maturation, both sugar acid ratio and color, plant trees further apart. To decrease rate of fruit maturation, of course, do the opposite, plant trees closer together. Let's look at yield. This is from, again, this Boswell experiment, the one planted in 61. They planted it in 61. Here's the annual tonnage of fruit from the period 65 to 69, first 5 years. Here's the second 5 years, and this is the 10-year average. This would be annual fruit production. So we take the cumulative yield divided by 10, basically. This is what we get. So there's the wide spacing, 90 trees per acre. And you can see compared to the 11 by 22, which is 180 trees per acre, we roughly only got about 60% of the fruit in this first 5 years that we did in the closer spacing. However, in the next 5 years, the 22 by 22 outperformed the closer spacing. And this is probably due to some tree crowding characteristics here. So if you want early fruit yield, plant them close together, but this tends to decrease with time. The closer spacings still beat out the wider spacing over the 10-year average, but it wasn't as huge as it looked like it was going to be early on. I'm not going to look at net income. It can be easily skewed by year-to-year changes in the orange market. So I'm going to continue with our take-home messages. So higher planting densities increases early yield per acre, but comes with increased cultural costs, such as greater pruning costs when trees reach maturity. Our harvesters still have to get around the tree to pick the fruit. And in general, profitability should be improved by matching your tree density strategy with the right cultivar and rootstock. For example, if later maturity is desired, start with something like a late Australian navel, grafted onto a trifoliate rootstock. And then based on your tree density, you can kind of improve the lateness or earliness of the fruit. So the perfect plant spacing for meeting multiple objectives for fruit quality and yield may not be possible. Let's do a hypothetical example here. Say we want to maximize our profits by adjusting spacing for an early maturing mandarin as follows. Say we want early, more intense fruit color, which would suggest we need a low tree density. Say we want high earlier fruit sugar acid ratio in the juice. Again, a low tree density. Say we want small, moderate, for example, acute fruit size in the mandarins. That would suggest to keep fruit size smaller, we want a high planting density. We want high early yields. We want a high plant density. So we got conflicting things going on here. So in the end, you're going to have to decide which characteristic is more important for your bottom line. But we do have this ability to change things somewhat as far as what our final crop's going to look like. So this is the last observation I'm going to do with respect to tree density. So the rate at which trees grow in a high density orchard will be slower due to inter-tree competition for light, water, and nutrients. This may offset some future pruning costs related to early tree crowding down the row. That's going to be inevitable at closer spacings. For example, topping and hedging may not need to be done as early in the development of the dense orchard or as often in densely planted orchards. So you do kind of slow the trees down by planting them close together, even though our yields will be higher because we have more trees per acre. I'd like to switch the topic now to pruning. So why do we prune? Here's some possible reasons for pruning. Certainly not all of them. We want to control tree height or width. We like to get our machinery into the orchard. It may provide strong scaffolds for fruit bearing. Possibly we could increase light penetration into the tree canopy. More open canopy, we probably get better pesticide spray penetration. We can reduce certain mite or insect pests or improve environment for beneficial insect. Of course, that's very dependent on the particular insect pest. Very hard pruning is done sometimes to try to rejuvenate trees that aren't performing well. And I hear people that like to prune to get better fruit size. So let's look into some of this. Before we know how we want to prune, we kind of need to know how the tree grows. So the trees in California, generally the ones we plant, were selected for an upright growth habit. They're, I guess, now in Europe and whatnot, they're working on some more trailing type citrus varieties for putting on trellises, but we have upright trees here. And generally, the way citrus grows is, though, as the fruit grows during the season, the weight of the fruit and the leaves are going to pull many of the branches over like this. We get these branches that pulled lower toward the ground. And what this causes is generally that the new growth will start to grow from where these branches curve over. And the reason for that is in a new shoot, these terminal buds produce auxin. Actually, all the buds produce auxin. But as these terminal ones, gravity will tend to pull the auxin down the branch, and auxin levels get high here, and it kind of tells these buds here not to push. So most of the push occurs toward the tips of branches. And this is basically what's happening here is these branches curve over. These buds here toward the end of the branch, they're now pulled over. Gravity is not pulling the auxin down the branch as it was. The high point on the branch is now where the auxin is at such a level that encourages the buds to push. So we get kind of a sort of shells of different growth in a citrus tree. We get the trees push, the weight of the fruit pulls them over, and new buds tend to grow here at the new high point of the branch. And with time, this just repeats again. This new one will do the same thing. It'll pull over, and the new leaves and new shoots will come out of this portion. So we tend to have shells of shaded, underproducing dead branches in the interior of the trees, with our fruit production here on the outside of the tree. Here's a real branch, not the idealized one I was showing, and it shows pretty clearly what happens. This branch was fortunately outside the canopy, so I could take a pretty good picture of it. But as this branch grew out, again, the weight of the fruit and leaves pulled it over, and you can see the new shoots are produced here. And this is, so in citrus, we don't tend to make heading cuts like we do in stone fruits. And with a stone fruit, this branch would have come up, we probably would have clipped it here to encourage the growth here. You don't have to do that with citrus. It sort of curves over, it does the work for us. We certainly wouldn't do that before the harvest, but once we harvest, we really don't need to cut it anyway, because these leaves are still going to help with the photosynthetic production of the tree. It's going to feed the tree. So with citrus, we tend to not have to do heading cuts. What we tend to do is thinning cuts and more undercuts, especially to get rid of dead shaded tissue in the interior of the tree. I've got a short video that I'm going to play that kind of demonstrates the anatomy of a typical orange tree in California. I think it illustrates pretty well how citrus grows. I want to warn you, it was developed for landscape or backyard citrus audience that like a more open tree. So whatever you do, I'm not recommending that commercial citrus trees be pruned as severely as these trees, or even if at all, some of our later data in this presentation may show. But I do wanted to show you this because I think it does illustrate how a citrus tree grows and some of the important anatomical parts of a commercial citrus tree in California.
Really, the best way to approach pruning a citrus tree is from the inside out. So right now we're under the canopy of this citrus tree, and the reason we can get so far and deep into this tree is that we did prune it a couple of years ago. And with citrus, it's probably best to prune it lightly more often than to make draconian cuts later in a single effort. First, I'd like to kind of explain the anatomy of the typical citrus tree. Citrus trees are grafted onto rootstocks at the nursery. And you can see here, on this tree here that's probably 10 or so years old, you can see the graft union. The rootstock is chosen for several reasons. It's chosen for root rot resistance generally, and it will also advance the flowering and the fruiting date of the citrus tree. So you should be able to see this in your backyard tree. Now, there are some rootstocks that grow at about the same rate as what we call the scion. That's the fruit-bearing part of the tree. And it'll be more difficult to see this. Sometimes trees are planted too deep, which defeats the purpose of the rootstock. So if you've got a deeply planted tree, sometimes you may see fungal infections here. But the reason I'm mentioning this in regard to pruning is that this particular rootstock is a different genus than is the scion. That means it produces fruit very different from the fruit we eat. So any shoot, such as this one here, will have to be removed. Notice this is what we call a trifoliate type rootstock. That will help you ID which is rootstock wood and which is scion wood. But you can see it's got a trifoliate leaf. So that definitely says that this is rootstock wood, and it's going to produce a yellow, bumpy, very sour fruit. So one thing we're going to do, and you as a homeowner will need to do, is remove any rootstock suckers. And you're going to want to remove them as close to the base as possible so they won't tend to regrow. Citrus is very interesting in that wherever light hits it, even in a mature branch like this, there are adventitious buds that will sprout. So one of our goals in pruning the citrus is not to remove too much wood from the top of the tree, because it will really produce many what we call sucker sprouts, or if they're produced on the scion, lower part of the wood here, we call them water sprouts. And you can see this tree has numerous water sprouts, even though it's in the shade. And generally, in pruning citrus, we want to remove those sprouts. Given time, this juvenile, we call juvenile or young wood, will produce fruit. However, there's no need for branches down here. If for some reason one of your main branches, these large branches, which we call the scaffold branches, are damaged, you can train one of these to be a scaffold branch. However, like I say, if you've got a full canopy, these are unnecessary. They're just going to crowd the interior of the tree and provide better habitat for some of our less desirable insect species. So when we're pruning citrus, we want to remove these lower shoots. And again, try to get them as close as you can to the actual trunk. You can see in the past we haven't done a very good job here with some of these. But again, we're inside the tree, and you can see from the inside out, this is the skirts of the tree. And again, on the citrus, we want to avoid cutting back the outer canopy. Citrus is born on wood that is approximately 1 year old, and if we just cut from the outside of the tree in, we're going to cut off all of the foliage that's going to produce this year's crop. So again, this is one reason we're looking at the tree from the inside out. The key to pruning citrus successfully is to understand how the tree grows. In this particular shot, we have a scaffold branch here, and we refer to these large, thick branches that support the canopy of the tree as a scaffold. And if we follow this particular scaffold along, we can see that the tree grows somewhat like a fountain. What happens is we get a young shoot, it grows upward, and generally on the upright shoot, we have something called apical dominance, which prevents side shoots from growing. However, as the season progresses, the weight of the fruit increases, the weight of leaves increase, and this shoot will begin to bend over. At the point where the tree bends over, apical dominance is released, and we tend to have other shoots grow. So you can see somewhere in the past that we have shoots beginning to grow at what is now the high point of the branch, because this branch would have curved over, come down like this. At the highest point of the branch, these shoots begin to grow. They grow up. The weight of the fruit and leaves eventually pulls them over, and the process is repeated. And we can trace this in the history of this branch. You can see somewhere in the past when I pruned this tree, I removed a branch here. This was the downward facing one. So really, when we prune citrus, we generally make what we call thinning cuts. And generally in citrus, they're undercuts. This is quite different from what typically happens in stone fruits. So if I were to prune this particular scaffold, you have a branch here that's coming down, but now generally this branch is shaded. What happens is as it grows like a fountain, these interior branches that are bent over are shaded, and they basically die, or they become very unproductive. So as you can see here, where some of these other branches have now grown upward, shaded these, we call undercut these now shaded and unproductive branches. So what I'm doing here is making an undercut. We're going to remove some of the canopy, and you notice as we take care of some of these branches that we're also thinning the skirts, as it were. So we really need to do very little pruning from the outside of the tree. As we do this interior pruning, we're going to thin the outer canopy as well and get rid of our less productive branches. And I can do this in several locations. There's a lot of branches that have since become shaded due to the growth of these new shoots from the top of the tree. Now there's still shoots being produced up here, but many of these are just growing straight up through the canopy, and we don't like shoots that grow straight up from the bottom of the canopy through the top of the canopy. These are juvenile shoots, again characterized by this kind of triangular wood, very typical of citrus. Again, these can make a very useful branch at some time in the future if you need them.
Well, thank you for watching the video here. Let's see if we can get out of it. Let's get back now to commercial citrus. And of course, with our large acreages, we have big machines that can help us do the pruning. Here we have topping, hedging, and hand pruning. And these are all used by most growers at some time. So if it's too late to change the planting density, we can still change the size of the tree, or that is our effective planting density, through our pruning practices. Generally, pruning of any kind reduces total fruit yield. Basically, pruning is a dwarfing operation. The goal of pruning is to maintain mechanized access to the orchard for production operations and harvesting, and possibly to improve fruit quality and increase profit. And we're going to talk about that in the near future. But don't prune if you don't know why you are pruning. It's a lot of work and thus expensive. So 3 things to remember: citrus fruits are produced on 1-year-old wood. 1-year-old wood generally is located on the outside of the tree canopy, and excess pruning of outer canopy removes fruit wood. Hedging, topping, and interior hand pruning is often less detrimental to yield if done lightly, more frequently, rather than taking a lot of outer canopy wood off at one time. So why do we hedge? Basically, it reduces the shading of lower branches and allows equipment freer access to the grove. Why do we top? Pretty much the same reason: reduces shading of the lower branches, and it keeps fruit closer to the ground. If light's not getting to the bottom of the canopy, you're not going to get any fruit down there. Some grows are gable topped or at a slant. This has possibly several advantages. It may allow more light into the lower canopy, and it definitely is easier to get the fruit off the top of the prunings off the top of the tree if it's done at a slant like that. The machine will tend to throw the prunings into the middles. Topping can improve the harvest efficiency of hand-picked fruit. Farming shorter trees generally means lower harvesting costs per picked carton and less risk of injury from manipulating and falling from tall ladders. So like we had a lot of different effects of tree density, a lot of things that can affect tree density response. The same thing's true of pruning response. Things like the tree health or the age of the tree. We have problems with stubborn in some areas, rootstock incompatibility. And these affect the vigor of the tree. The variety also has vigor effects, both the rootstock and the scion, the tree spacing, the severity of the pruning treatment, cultural practice such as fertility and irrigation, the timing of the pruning. Generally, we don't like to prune when the tree is covered with fruit, and significant freeze events. So there's a lot of different things that can affect how your tree is going to respond to pruning. And we like to have reasonable expectations. Mechanical hedging and topping are not a long-term replacement for manual pruning. You can get crow's nests in the upper canopy. I think I have a picture of one of those. You get no removal of dead twigs or crossing branches on the interior of the tree, which can affect the ability to build strong scaffolds to support the fruit. Here's some crow's nests. If you keep coming through pruning the same height, you tend to get these, which can really affect the amount of light available to the upper canopy. And of course, if you hedge too late, or you can get some exposed fruit, it's really susceptible to sunburn and whatnot. So to avoid excessive shading of the lower canopy, the tree canopy, closely spaced trees should be shorter than widely spaced trees. I think this is obvious. And we have some general guidelines that have been used successfully in the past for maintaining tree height for the production of citrus fruit for the table market. So tree height should not exceed 80% of the distance from trunk to trunk in adjacent rows. So here we have 20 feet between our rows, and using this rule, 80% of 20 is about 16 feet. So if there's 20 feet between rows, we like the trees to be 16 feet or less. And the distance between the outer canopy branches down the middle here is supposed to be about roughly 50% of tree height. So we have a 16-foot tree. Doing the math, 50% of 16 is 8 feet. So if we follow these rules, we should get sufficient light into the bottom of our canopy so we can have fruit over the entire canopy, just not at the top of the tree. If within row tree spacing is close, tree height should probably be reduced further. By following these guidelines, adequate light distribution to the lower tree canopy may be maintained, especially if hedging is done at an angle. So typically trees are hedged at an angle, something like 15 degrees from the perpendicular. So we've all been in tall tree orchards, and what we see in tall tree orchards is tree skirts rise in response to low light levels. The light simply can't get down there. So not only is there no fruit down there, but we really don't even produce leaves down there. So the trees will tend to get taller, but the effective leaf fruit-bearing area of the tree doesn't really increase past a certain point. So if the bottom of the tree skirt is 4 feet off the ground due to shading, you can probably cut 3 to 4 feet off the top of the tree without impacting yield. So as is the case with tree spacing, topping and hedging can be used as a tool to influence fruit quality and maturation as well. Taller trees, that is those that are topped at a higher height and less distance between outer tree branches, less hedging, will result in a shadier and cooler orchard, resulting in delayed fruit maturity and smaller, less granulated fruit. This is just what you might want for growing a late Australian navel. And I've also seen this used in controlling weeds in an organic orchard where weed control is always a problem. If there's not enough light to put leaves on the bottom of the tree, there's not enough light to grow weeds sometimes. So just rhetorically, what would we do pruning wise to our trees if we wanted more illumination and a warmer orchard? For earlier fruit maturity, higher early sugars and earlier color, reduced intertree shading and open up the canopy. Pruning can affect many things. Severe pruning can reduce water use through reduction in canopy size. More open canopies generally are hotter. Less shading of fruit can increase sunburn. And citrus thrips. Citrus thrips love the outer, warmer fruit on a tree. Most scale insects that attack citrus, such as California red scale, cottony cushion, and citricola scale, can be more of a problem in unpruned shady tree interiors. So what follows is a case study in the relationship among pruning severity, yield, and fruit size in navel orange. This experiment was conducted in the southern San Joaquin Valley, actually along Highway 65. So the objective was to determine the effect of hand pruning and topping on yield, fruit size, and grade of navel orange. The experimental orchard was located in northern Kern County. Spacing was 22 feet by 22 feet. It was originally 11 by 22, but every other tree was removed down the road to make it easier to harvest the fruit. At that time, they were 37-year-old frost Nuceller navels. I guess now they're probably more closer to 60 years old. Previously, these had little interior hand pruning, but were regularly topped at 15 to 16 feet and hedged. At the start of this experiment, most trees in the orchards were probably closer to 17 feet tall anyway. We had 3 topping treatments, and 3 interior pruning treatments. And the interior pruning treatments required hand labor. This is the way one of the plots looked. It was the tip plot was 9 trees long by 4 rows wide. And these subplots here were 3 trees long by 4 trees wide. And the only data that was collected were the 2 trees in the middle. These other ones, we wanted to make sure that the trees in the middle were experiencing the same degree of hand pruning as those surrounding them. This shows the entire plot. I just show this to emphasize the 3 topping heights. We had 3 topping heights, A, B, and C. Of course, they were replicated. A was no topping. B was they were topped at 16 feet. C, they were topped at 14 feet. And the topping was only done in the years 2000, 2001, and 2002. The experiment ran into 2003. We didn't do anything in 2003 to the trees. The pruning severity, they were, again, we have these subplots here, and 1 is no hand pruning. 2 was just dead brushing. I'll describe what we did there. And 3 was severe hand pruning. The severe hand pruning was only done in the year 2000. They were dead brushed thereafter, and it was very severe. We wanted to see what would happen. And these are some of the most severely hand pruned trees. I wasn't there to watch all of what was being done. I was kind of shocked myself how much wood was removed. But the severe hand pruning was only done in the year 2000. This is the way they were dead brush. This is pruning severity number 2. And we removed the skirts to a distance of 2 feet. And then we sort of removed this cylinder of wood here. That would have been up to 7 feet. Mostly this was dead wood, but obviously there were a lot of shoots because these had not been dead brushed previously, at least not to a huge extent. So there were shoots that were removed that went all the way to the top of the tree. So this did entail some thinning of the upper canopy. And then we had treatment 3, which was no hand pruning. So we had some trees that were not topped and were not hand pruned at all. So right after we started the experiment, we started weighing the wood that we removed. So as far as the topping treatments, the ones that were not topped, obviously we didn't remove any wood. The 16-foot height, we only removed about 4 pounds on average. So these trees were not really that much taller than 16 feet when we did this experiment. At the 14 feet height, we removed a lot of wood, 53 pounds. This is on a wet weight basis. Interior pruning, not pruned. We didn't remove anything from the interior. Dead brushing, moved about 70 pounds of wood, which is fairly hefty, considering these trees probably only weighed about 600 pounds to begin with, based on some trees that we completely dismembered. And severely, we moved about half the wood of the tree, which is very severe and not recommended, but we'll look at the data. And just to remind you, this was a 4-year experiment, but in 2003, we didn't do any topping or interior hand pruning. We let everything rest. So trees were hedged on both sides and only in 2000. These were older trees, not all that vigorous, and that hedging seemed to allow us to maintain moving equipment into the orchard with no problem. And the topping was conducted at 14 or 16 feet every year. All treatments received the same amount of nitrogen per acre. Nitrogen was applied foliarly 2 times a season as LB urea, which is very efficient, and with a tank truck on the ground once a season as UN32. Fall sample leaf nitrogen was about 2.2% by dry weight, was not significantly different among treatments. And irrigation water had to be adjusted initially in the severely pruned trees because they were staying very wet. So from 2000 and part of 2001, we changed the emitters to allow less water to those trees. Trees were harvested in late December or January over the 4 years of this study, and all the fruit was removed at the same time during the harvest season. And the topping at our heights didn't matter, as it turned out. There was no difference in fruit size or quality with annual topping among 14, 16, or untopped trees, or cumulatively over the 4 years. So these little A's here, as we go down here, there's the no topping, the 16 foot, 14 feet. Little A's mean there was no significant difference in the pounds of fruit per tree, the number of fruit per tree, or the number of fruit size 7248 to 48 per carton, which is sort of the most commercially valuable sized fruit. And when I compared topping height, I removed the severe hand pruning treatment because that was so severe, it just overwhelmed any difference in treatment height. But there was still a lot of data that went into this with the dead brushing and the non-pruned topping, the non-topped trees. So the hand pruning results were the ones that were most noticeable. One thing we found in the severely pruned trees, if we took a lot of a canopy off the top, we got just a bushing, just a tremendous spurt of growth on the interior of the tree. So thinning out was really not that successful because we ended up with a lot of brush inside the tree. And of course, this had to be removed when we dead brushed the trees the following year. This is a tree that was minimally pruned or not pruned. This is the 2000 season. This is the first year that when we really severely pruned the trees, and is not unexpectedly, our yield was not significantly different between where we did no interior pruning, where we dead brushed only. But so you can see the severe treatment, we had roughly half the yield. And of course, this was reflected in the number of fruit per tree. And it also affected the number of fancy fruit, oddly enough. And we think it was basically because these fruit generally grew misshapen and out of size. So we got a lot of very big misshapen fruit. And so the percent of the fruit that was fancy was significantly less than where we did this other type of interior pruning. This is again the 2000 season. If we look at the actual fruit sizes we got, the number of fruit per carton, of course, the bigger the number, the smaller the fruit. And you can see where we did no interior pruning or we only dead brushed, we peaked on size 72s, which is a good size to peak on. Whereas in the severely pruned trees, we peaked at something less than 48 per carton. And again, these are much tougher to sell than the ones over here. This is a picture of the severely pruned trees on the left in 2001. You can see the canopies are regrowing, but they're nowhere near as large as they are in the unpruned trees. So 2001, though, this shows where Mother Nature can trump your best efforts at trying to prune something. We had some very hot temperatures in 2001. It caused a very high June drop. So there was very little fruit on the trees, whether they were unpruned or pruned, it seemed to have very little effect. There may have been a slight numerical trend toward fewer fruit in severely pruned trees and trees topped at 14 feet, but we did not get any significant difference in number of fruit yield or fruit quality. We did our last topping in 2002, as I mentioned. And here's a picture of one of the severely pruned trees in 2002, showing our canopy was still not fully growing. We're getting a lot of light through the canopy, but as we'll see in the data, it wasn't enough. So here's the interior pruning effects of 2002 season, and no interior pruning. We had significantly more fruit per tree, especially compared to the severely pruned trees. The percentage of fruit larger than 88 was greater in the severely pruned trees, and this is undoubtedly related to the fact that we had fewer fruit per tree to size. The gross value, and this can really change from year to year, but no significant difference in the fruit value. And of course, whatever we made here, we had to subtract the interior pruning cost too, which was about $270 per acre. And of course, this is prices in 2002 for the fruit. So this is the cumulative value from the 4 years of the experiment, and the severely pruned trees never recovered to the same yield as the unpruned trees or the dead brush trees. The fruit number per tree, we were reduced there, probably about 2/3. The percent that was less than it was greater than size 88. That means fewer fruit per carton. You can see we had 83% were greater than size 88, and only 70% here where we did no pruning at all. But here's where we kind of lost out. The number of fruit 72 to 48, we had 2,200 cumulatively per tree. In the non-pruned, the non-hand pruning plot. Dead brush was somewhere a little bit in between, but not significantly different. And we did have significantly less of these commercially valuable size fruit to sell. As far as interior pruning cost, if we look at the severity of the pruning and the dead brushing, we spent about $13 per tree in the severely pruned plots, $8.25 of the dead brush plots, and of course we saved all the money in the no pruning plot. So why did interior hand pruning affect yield and fruit size and not topping? What we think is when we went to 14 feet, basically, we didn't change the total leaf bearing area of the canopy. We just moved the bearing leaf canopy down. In the taller trees, the 16-foot trees, for example, or even the ones that we didn't top at all, we had area here where there was no fruit. We just weren't getting enough light down to the tree. So what we did is we really gained in this thing. We have shorter trees. but we have the same amount of fruit basically, because all we really did was move the bearing area of the canopy down the tree. Hand pruning, on the other hand, we had trees where we were getting plenty of illumination where we could have had fruit, but due to our severe interior pruning, we removed big gobs of canopy, which just gave us fewer places to put fruit. So that's why we ended up with fewer fruit per tree in the severely hand pruned plots. So there's other considerations to consider here. We just don't prune for fruit size or fruit numbers. I think one reason that our topping and some of our interior pruning, the dead brushing were not as effective as they might have been. We had low disease pressure in there. We didn't have much anthracnose staining, and we tend to see more of this where we have a lot of dead branches in the interior tree. Calytotricum, for example, is always there, but we need wet conditions to get it to go. And this was in Kern County, tends to be dry. So we didn't have a problem with a lot of diseases here. Scale insects were not a problem in this orchard, so spray penetration to the canopy was not an issue. Perhaps if we'd had a lot of pests, we would have seen better results as far as the improved quality if these pests were a problem, which they weren't. So we also did not measure harvest efficiency gains or safety issues are not reflected in the economic results. For OSHA frowns on 20-foot tall trees, as do some picking crews. So we didn't figure in any harvest efficiency gains we had by being able to pick shorter trees. Now, this is the part I think of the data that's the most interesting. So what is the relationship of total fruit numbers per acre and canopy volume and large fruit in navel orange? What can fruit yield and fruit size tell us about the utility of pruning? So let's look at some of the graph data here. Here we have average yield of fruit, pounds per tree, and here we have the wet weight of hand pruned wood. So as I've already said, here we removed about 325 pounds of wood. Our yield was less than 280 pounds of fruit per tree. Where we didn't remove any wood, we had about 460 pounds of fruit per tree. And it's not surprising, here we have on the x-axis the annual yield, tons per acre of fruit we produced. This is the total annual fruit numbers. The more tonnage we have, the more fruit we have. And I guess that's pretty obvious. What I was surprised at is how linear this function was. Here we have the results from 2000, the first year. Here we have the annual total number of fruit per acre in thousands. And you can see some years we were up to around 100,000 fruit per acre. Here's the economically valuable fruit, sized 88 to 48 per carton. These are the ones you can sell the easiest. And it looks like a fairly linear relationship. Here's the severely pruned fruit. And you can see we had about 30,000 fruit produced, and we had about 20,000 to sell. They were of the economically valuable ones. The blue is no interior pruning, and as you can see, good yields, probably 95,000 fruit per acre, and we had something like 73,000 fruit to sell. But I found it kind of impressive about this was that they seem to fall in the same line. So even though we had fewer fruit here, we didn't get more economically, it was on the same line as these ones over here. So as we continue to do the experiment, we found this held true for the entire experiment, that there was just a linear relationship between the total number of fruit produced an acre per thousands and the number of fruit sized 88 to 48 to sell. And the more fruit we were able to produce, the more we had to sell. You can see this is the data from 2001 when all the fruit fell off the tree due to June drop, fell on the same line. So Mother Nature limited our production to probably about 38,000 or so fruit. We only produced 50,000 fruit. So what this suggests is that what we want to do with navel orange, our mid-season navel oranges like Washingtons and Frost New Cellars, pretty much have an ability to size all the fruit that's on the tree according to this relationship. So what we want to do, we want to maximize the number of fruit on the tree. We don't want to prune the trees heavily unless there's some other reason. We want to have as much fruit as we can because these trees can size it all. So if there are those of you out here that are pruning their trees very hard for every year, trying to get more fruit per acre or get bigger fruit per acre, I think it's unnecessary. It looks like those trees have the capability in our climate to size almost all the fruit that ends up on the tree, again, according to this relationship. So we don't want to have 70,000 fruit produced totally because we only have 60,000 to sell. We want to have 110,000 fruit produced, so we have 95,000 commercially valuable fruit to sell. There's another relationship that isn't actually that obvious here, but this is the relationship between the annual number of fruit per acre in thousands and the percent of fruit larger than size 88. And as you can see, I guess you could brag that this person could brag, well, I got 95% of my fruit were larger than size 88. However, if you look at this, if you've got 40,000 fruit, 90% of your fruit are larger than size 88, that means you only have 40,000 to sell. Whereas over here, say you've got only 70% of your fruit was larger than size 88, you produced 100,000. That means you've got 70,000 fruit to sell. Would you rather sell 40,000 or would you rather sell 40,000 fruit? Or would you rather sell 70,000 commercially valuable fruit? So fruit, the percent of fruit of large fruit on the tree is deceiving in many ways. We want to have a lot of fruit that's on average commercially valuable. And the same thing in the same experiment, it is held for individual fruit sizes. The blue is 56, the size 56 fruit per carton. And you can see again, the more fruit that we had per acre in thousands in the orchard, the more size 56 we had to sell. Same is true for the size 88s. So again, doesn't look to me like we want to thin the fruit. Doesn't look to me like we want to try to prune to get bigger fruit. It looks like the trees are doing a great job of producing the fruit unpruned. So the conclusions of the trial: annual topping frost nucellar navels spaced at this spacing to a 14 or 16 foot height. Had no negative effect on fruit numbers, size, or yield. So topping makes a lot of sense. We ended up with smaller trees that were easier to harvest, and it didn't cost us anything in fruit size or yield. However, attempting to increase the number of fruit size 88 to 48 per carton per acre in frost nucellar navels by hand pruning was not successful. So why do we want to hand prune, or why do we want to try to thin the trees? And we had a constant linear relationship between total fruit numbers and number of commercial sized fruit appeared to exist, regardless of pruning intensity or weather-related effects. Remember the June drop. So I wanted to look at this a little further. And what I did is I tried to throw every experiment I did on mid-season navels in, where I sized the fruit, and to try to determine if this relationship holds for in general across orchards in Kern County. I also look at 3 bonanza or Thule gold orchards, which is a different kind of a fruit. You don't see these very often, and the data will say why, but there was a time we had a lot of these orchards because the fruit matured so early. And some of these trials involved fruit thinning. Some were the pruning trial I just talked about. There was an insecticide trial in here. So this is all the data I had. And you can see it still falls on the same line, basically, as far as the Washington and Frost nucellar oranges. The mid-season oranges still held to this relationship, suggesting why would we prune? Why would we try to thin them? So I think I've talked about this. I just talked about this in the last slides. Now, so let's look at some of the data from the Thule golds and the bonanzas, and this is really informative. The red line are the mid-season oranges. Again, we get this linear relationship going up all the way to 100,000, 110,000 fruit per acre. But look what happens with the bonanzas and Thule golds, the bold line. It looks like things are going fine until we get about 70,000 fruit per acre. Then things go sideways on us, where we end up with a lot more fruit. We can get up to 140,000 fruit per acre, but we still only end up with 70,000 commercially valuable fruit. So in a case like this, look at down here, this is really horrible. We had almost 140,000 fruit per acre, and we only had about 6 or 7% that were commercially valuable. I remember even the harvest of this one, the harvest crew actually walked off because it takes a long time to fill a bin with golf ball sized fruit. So in the case of the bonanzas and Thule golds, it might pay to try to do some pruning or fruit thinning. We don't really have a good way to prune the thin citrus fruit, however. So I was not successful trying to do this. So I think what we saw was the farmers voted with their bulldozers, and a lot of the Thule gold and bonanza fields, even though the fruit was very early, no longer exist. So let's look at other varieties, the navel. Let's look at Mineola tangela. We worked with those over a while. And as you can see, we ended up with a very similar relationship as we did with the navel oranges. We looked at jumbo, mammoth, colossal, and super colossal. Those are the kind we think are probably the most commercially valuable. And we got the same relationship. Again, why would we prune? Why would we try to thin? Because it looks like these trees, again, according to this relationship, are able to size everything that they produce. The more fruit they produced, the more commercially valuable fruit we had to sell. This is a question I get asked occasionally. So what about pruning for more high quality interior fruit? A lot of times the interior fruit is less marked up. You have less trouble with some insect damage or tree rubbing, wind damage, what have you. But it's been my observation that most interior fruit or fruit produced in the outer canopy, the weight of the fruit pulls them into the tree interior usually later in the season. I think trying to increase interior fruit from shoots produced inside the tree canopy will probably result in removal of too much outside canopy, excessively decreasing yield per acre. And of course, to produce fruit, you need light. So just trying to get a lot of light into the canopy for shoots that are in the interior of the canopy is tough to do. And I don't think it's worth trying to prune for that as an objective. Thank you for your attention. I think we have some time for questions, if there are any questions.
Thank you, Craig. We really appreciate your presentation. We are going to go ahead and ask some of the questions in the chat. So if you have any questions for Craig, now is the time to add them to the Q&A part of Zoom. Christina asked if there's a recording of the session that will be available. Yes, it will be available on our website. Albert asked, in regards to tree density, is there any difference in water and nutrient costs? Is there any benefit to offset spacing or slopes?
Yeah, those are a lot of questions we can't answer, but definitely as you increase the tree density, your irrigation and fertility cost will be somewhat higher because you're covering the ground, you're growing the canopy quicker on a per acre basis. So the cost will increase. I think I've got a chart where I sort of estimated the increase in water use from a closed canopy versus one that was more open. What was the other part of the question?
Is there any benefit of offset spacing or slopes or any effective slopes?
Yeah, the trouble with offset spacing, I just am not aware of any data where anybody's done those kind of experiments. They're extremely difficult to do, and I have no data on that. The slopes, and again, another interesting question. One thing we do find is we get quite a difference in maturity between south and north facing slopes as far as the development of the fruit maturity and sugar acid ratio. So the earliest fruit that we tend to have in Kern County is usually growing on slopes that are south facing.
So in your case study, what was the age of the tree density when it was reduced from 22 to 22?
Oh, I don't know if I ever found that out, but in our own experiment, those trees were thinned way before we started the experiment. Oh, that was many years before. So when trees start to crowd, it becomes much more difficult to harvest the fruit for growers, for the harvesters to get in between the trees and whatnot. So I suspect that orchard was thinned probably 10 years before we even started our experiment.
So in regards to pruning, when or if do you do skirt pruning? Is there any benefit of pruning at longer times, say 5 to 6 years?
Yeah, the main reason we skirt prune is it reduces some pests. I mean, the fruit that's on the ground tends to be more susceptible to fungal disease like brown rot. There's usually snails are more of a problem. And ants have better access up the tree. So those are the reasons that we basically do the skirt pruning. If it wasn't for that, there's a lot of yield that's produced on those lower skirts, assuming the light can reach them. So most of the reason we do the skirt pruning is to reduce problem with fungal diseases and whatnot, and some diseases that end up with the fruit going to the packing house and causing problems there as well.
So is there any research on lemons for the same analysis? I think he means about pruning.
And no, there isn't that I'm aware of. But lemons have their own challenges. Where I show where the shoots tend to bend over with the weight of the fruit and the leaves. But lemons are so vigorous in general that they don't tend to bend over. So you get these great big, thick, upright shoots that go straight up through the tree. And so it's not like they grow so fast that often when the trees are still growing and when they're growing rapidly and going from juvenile to fruit bearing, that there'll only be fruit in the bottom third of the canopy, and it's further complicated trying to harvest it by the thorns and whatnot. So lemons are their own nightmare. I really don't even have some good suggestions. I had one grower I worked for that tended to reduce irrigation during the summer. And that kept the lemons from growing out of size, from getting too big. And it also reduced a lot of that really vigorous growth. So that's something growers might be able to experiment with, is just to cut water use during the summer, maybe by 20% or so, just to see if that takes some of the vigor out of the lemons and reduces the need to prune at all.
So do you have a preferred timing of citrus tree topping? Some varieties are so vigorous that early topping results in a taller, more vegetative tree than you started with.
Yeah, and again, we don't have good data on that. And it probably depends from variety to variety, because of course sometimes we have Valencia oranges, you know, where we're harvesting the main crop during the summer, as opposed to the other citrus varieties which we tend to harvest, of course, during the winter. So that can play. You don't want to do any of this when you have a fruit that can really get dinged up by the pruning. So that kind of limits when we can prune. And so a lot of times with for instance, navel oranges, we tend to prune in the spring, sometimes even during flowering. The tree produces so many flowers that won't set fruit anyway. Removing some flowers doesn't hurt anything. Or we can try, it's harder to ding up really tiny fruit, but sometimes people will prune after the harvest in the fall or in the winter. That used to be kind of problematic because we worry about increased frost hazard, but you know, way overdue for a bad frost. So I don't know if global warming's kicking in or we've just been lucky, but I see more people pruning during the winter now than they did early spring than they did in the past. February's been a good time, I think, for a lot of the citrus. Again, assuming you don't have fruit on the tree that needs to be picked.
So is there any significant relation between economic value and output and pruning?
No, I don't. We don't have any great data on that if you actually prune the tree. But as I tried to suggest here, it looks to me like with our citrus trees here, if we top them at about 14 feet, we don't need to do a lot of pruning. We're going to kind of maximize our yield. And other results, you know, as far as scarring from wind or what have you, that's very orchard dependent. It depends on the weather, the wind, you know, these particular insect pests you have. So I was trying to make that point in the presentation that it's hard just to make gross generalizations, and you kind of have to adapt to your own conditions. If you have a lot of trouble, I know some of the mandarin varieties have trouble with scale insects in the interior. And so then you're going to prune for that more so than trying to maximize fruit quality that problems may be caused by something else. So it's kind of almost orchard by orchard. But what I'm trying to get the idea across is you don't have to prune, all else being equal.
So why do you think so little research has been done on citrus pruning in California?
Well, the experiments are a nightmare to do. And again, it varies so much between orchard to orchard that what you get in one orchard may not be very applicable to another orchard. Actually, when this research was conducted in the early 2000s, I was kind of horrified in a way at how much money growers were spending on controlling tree size and all the costs of all that interior pruning. And the objective was to increase the percentage of big fruit in the orchard. But I don't think they realized that they were reducing the total number of fruit to such an extent that it was self-defeating. And I'd also like to, I mean, it's much easier to harvest the shorter trees that may be excessively short. I see 12-foot trees and whatnot. But if a grower is doing a lot of extra pruning and whatnot, it might be worth just setting a part of the orchard and not doing that and just compare the results with it. Because like I said, there's a lot of interactive things going on between insects, wind damage, and who knows what else. And it's just hard to make huge generalizations on the value of pruning or not pruning.
So what would be your recommendation or your pruning recommendation for mandarin trees? Mechanical hedge, chop and skirt with no interior, or hand pruning?
Yes, so we don't have much data I know mandarins have just been taking over, and we have almost no data whatsoever on mandarins. So I hate to make gross generalizations on that, but citrus varieties, especially mandarin oranges, are not really that different in a lot of the things, their maturity, what have you. So I would definitely consider if I was doing a lot of pruning on those trees. And again, it kind of depends if you want to get a lot lighted, if you're talking about early maturing ones versus late maturing. I think these things all need to be taken into effect. And if I was doing a lot of pruning, I think I would reconsider. I realize with some of the early ones, and some of the late and early, you've got to put nets over them. And of course, that's going to affect how you prune the tree as well. And I just have no experience in growing the mandarins. But there's things that don't seem obvious at the time, but I guess once you're out there trying to put those nets over the trees, you got a lot of wild, heavy shoots that are up there. That could be a problem.
So what about the timing of hand pruning and the effects of changing the shoot or the root ratio?
Well, again, we haven't a lot of data, but what I was trying to suggest from this with the interior pruning is, again, consider why you're doing it. Is it really paying off? Again, at the interior pruning, you end up with a lot of those shoots. They go up through the tree, at least to some extent, or those big shoots. If you kind of do it when you plant the orchard, that's probably the best way. You don't get it. But if you go back like we did and try to do a massive interior pruning, we cut a lot of pretty big shoots that went all the way to the top of the tree, and we really thinned out the outer canopy, which cost us a lot of yield. So in general, interior pruning, probably with navels, is I really like February, early March for a lot of that. And again, we don't want, if it's late navels, we're not going to be able to get in there and do it because we're probably still holding them on the tree. So again, these are all important considerations. There's usually never a great time to prune citrus because the fruit's just on the tree for so long. We store the fruit on the tree, which is a great way to store fruit. It's better than putting it in a cooler somewhere, but it really limits our option as to when we can prune.
So what do you think about double density planting with eventual tree removal in less than 10 years?
Yeah, I'm really interested in how this sort of things have turned around, and we're planting the trees so dense. And again, I think it depends what your goals are. If we're looking for late mandarins, for example, where they we want them to hold on the tree a long time, we don't want them to get huge, that we can probably hang on to those dense orchards for a long time, especially if we keep the tree height down, which we may need to do to put nets on them sometimes. So I think you need to know, what is your strategy? What do I want to sell? Do I have early fruit I want to sell, which we probably have more of a clementine type mandarin? I think those double density things make a lot of sense under some certain conditions, but tree removal is extremely expensive, and growers don't like to do it because the poor person that actually thins them out, they'll see the yield just go, the yield might be half. And of course, it's hard to explain that to your boss if you're managing a farm as to why your yield went to half. So I don't know what to recommend, but I think if you look at the economics, tree removal in 10 years, I think is probably going to be way too expensive. And again, I would try to plan my tree density based on the type of mandarin, the kind of maturity I wanted and whatnot.
Does severe pruning rejuvenate poorly grown trees?
There is some data on that, and we used to do that, but it's not that effective. It's not that effective a rejuvenation meaning. And a lot of it was done on trees where we had the late stage incompatibility, where the rootstock overgrows the scion. And in a case like that, it really doesn't work very well. We have learned a few things that looks like help some of those orange trees, those older orange trees that have the late stage incompatibility with the rootstock, but trying to what we used to call buckhorning the tree just hasn't been very effective.
Are there any benefits of skirt pruning in regards to frost protection?
Again, I am not aware of any research on that. I can kind of see what they're getting at there, but I don't know.
And then our last question, Anna was just asking if you could restate how frequent you recommend pruning.
Well, again, this kind of depends on your goals. I know we feel like we should be pruning, but I think you can, based on some of the data we have, you can make a good case that you may not need to prune trees at all. Obviously, if a branch falls off and blocks the middle and you can't get your equipment by, you're going to have to do something. But as far as topping, I think taking a little more off less frequently or more frequently is probably better than going in there and make draconian cuts. For instance, we had, like I say, we moved 53 pounds per tree where we cut them from the 16-foot height to the 14-foot height. One thing I didn't mention on that experiment is that our cooperator there was Bruce Kallsen, and he was an old timer when I started this experiment with him in 2005, as far as his experience in the nursery, in the citrus industry. And we pretty much ended up looking at what he was doing in the orchard, and that's pretty much what looked like produced the most fruit. So that was pretty impressive. So actually learned quite a bit just by the grower we were cooperating with there.
Well, thank you, Craig. That looks like all the questions we have right now. I'd like to thank Craig for sharing this information with us today and to our participants for joining the Citrus Research Board for today's webinar. Please make sure to mark your calendars for the rest of our webinars. Next week, we have Dr. Jim Anaskavage giving an update on sweet orange scab and decay management strategies. And on June 20th, we have an overview of California lemon trials by Dr. Glenn Wright. And then on June 27th, we have the California water efficiency strategies with Dr. Franklin Gotti. Thank you again to everyone that joined us today. To stay up to date with upcoming CRB events, be sure to visit our website, citrusresearch.org. We'll stay on a few more minutes if there's any more questions, but if you'd like to get in contact with Craig, I have his email right there on the screen, and you're welcome to give him an email, send him an email.
Okay, thank you for the opportunity, Caitlin, for letting me talk.
Of course, thank you so much, Craig, and we appreciate everyone that joined us today.